My name is Peter Wilson. I'm the Technical Director at the Industrial Noise and Vibration Centre. Today I'm going to be talking about how you can reduce the risk of hearing damage at virtually no cost by finding out just what is possible using the latest technology and best practice in noise control. One of the problems with noisy plant is the cost. Cost to health, noise-induced hearing loss causes tinnitus, and it also has an increased risk of dementia of about 9% if people have hearing damage. This is the single biggest preventable cause of dementia, and that's a massive cost to the country going forwards. There's also the direct costs and indirect costs associated with PPE. There's the hassle in risk management, policing, claims, audiometry. There's the problems with the communication and the ongoing costs of risk assessments, that most of which just tell you what you already know, that you still have a problem. The big issue with risk assessments is there's very little information usually included about noise control. In reality, PPE does not work very well in the real world. HSE research has shown it's not generally effective, and people are not unnecessarily going deaf without knowing it. In addition, nearly 2/3 of all risk management reports are inadequate. That's what the HSE say, and I would agree with that. We run the IOSH competency training courses, and the quality of reporting we see is dire. The advice on PPE is pretty poor. It just says wear PPE. Noise control advice is almost always completely missing, and the general knowledge about noise control even amongst consultants, and particularly amongst end users, is, I have to say, abysmal. It's based on very poor diagnosis or no diagnosis at all, and everyone falls back on the high-cost palliatives, so nothing is done. Noise-induced hearing loss is a serious cost to the economy, so it's time something was done. As proof that hearing damage prevention using PPE doesn't work, look at these claims. These are the claims over the years. In 2013, 2014, we're talking about £400 million per annum paid out in noise-induced hearing loss claims. That just proves it doesn't work. Moreover, information about why it doesn't work, about the performance of PPE, has been around for a long time. This graph is from 1996, and it shows in yellow, for plugs and muffs, the laboratory performance that you're told on the literature, compared with the actual field performance as measured, used in factories and on site. So earplugs that should give 25 to maybe 30 dB are giving you as little as 2 or 3 dB. Earmuffs, which should give you 20 to 30 dB, you're talking about 10 to 15 dB if you're lucky. This information has been around for a long time, but most people still don't really understand it. And another thing is that if you reduce the noise level by 3 dB, you have reduced the risk of hearing damage by 50%. Because every time you reduce the noise by 3 dB, you're halving the energy, which halves the risk. Again, people don't really understand that. In the real world, noise levels above 95, it becomes very difficult to guarantee hearing protection using PPE, and above 100, you're pretty well doomed. Now, it's brilliant if you can reduce the noise to below 85 or 80, as in the regs, but no matter what level you reduce it from, you are reducing the risk. So if you cut noise from 97 to 94, you have halved the risk. You still have to wear hearing protection, but PPE will work much better. So let's look at noise control as a serious option to reduce risk and costs. These are things you might not know. If you knew some of these things, what would you do? What could you do if you knew just what was possible in terms of noise control and how low cost it can be? For example, you can cut fan noise at source without silencers and increase fan efficiency by using aerodynamic aids. There are also these weird metamaterial barriers which allow air through, they're open, but not noise. There are also techniques for air nozzles, for example, that can reduce noise by 90% and reduce 20% less compressed air, so it actually makes the noise control project profitable. There are also waterproof and hygienic acoustic absorbent materials. You usually think of foams and fiberglass and rockwool. They don't have to be like that. There's also sound damped steel laminate, which looks like steel, sounds like rubber. As an engineer, it's only been around for 40 years. As an engineer, I really like this stuff. It's cheap, rugged, and hygienic. Let's show you a couple of examples. I've measured over 100 dBA from tape used to seal up boxes. Okay. So, quiet sellotape. Now, I think the idea of quiet tape is really cool, but maybe I should get out more. Another example is using laminated sound damped steel. So for chutes, hoppers, vibrating components, guards, etc., it's a very, very low cost, very, very effective noise control measure is just use laminated steel. Now, we have a massive database of noise control technology across a huge number of mechanical sources and aerodynamic sources. Now, many of these techniques are engineering source control. None of them involve enclosures. So if you're looking at this sort of technology, how do you access it? So you can get access to this database via our website, or you can contact us directly, and it's a no-cost service. So you can look at our website and enter your search terms to look through all the case studies we have, which is over 100, of controlling various types of noise source very, very cheaply and very effectively. Or alternatively, you can put together some information and just whiz it over by email. We'll take a quick look through, we'll compare it with the database and get back to you with the possibilities that you have to reduce noise levels. So the information you need is noise data if you have it, like noise levels from a sound level meter measurements, past reports for noisy plant, noise assessment and so on, pictures of each item of a noisy plant, and we use smartphone technology a lot, so all we need is a short video clip of each item of plant in operation. We can then look at the plant type and compare it with our database of past projects. And these include noise control technologies from across the planet. We also analyze the video soundtrack, get back to any questions about the operational factors and maintenance considerations for the plant, and then we can provide you with a very brief outline of what best practice would be in terms of noise control, also with the costs and what the potential noise reductions would be. In certain cases, we can also arrange to have instant feedback via WhatsApp whilst you're on site. So if you have a noise problem, you can either look on our website to find out what the options are, or email us direct and we will get back to you, no cost, with a list of the noise control options, likely costs, and what the reductions would be, so you can plan what would be the best risk reduction program for your particular site. So this is the process visually. Send us videos, sound, information about the noise sources, we analyze it, put it through our noise control technology database, and email back to you the options. Or you can do it directly off our website yourself. Looking through some of the techniques that can be used that most people don't really understand or know about, as far as fans are concerned, which is a very, very common noise source, usually, conventionally, there's a few high-cost palliatives that are used. There's silencing, enclosures, lagging, barriers, and building modifications. However, there's a whole technology that's not usually considered. Quiet fan technology is a bit like Formula One. What we do is we design aerodynamic inserts that fit inside fans to improve efficiency and cut the noise. It's a fraction of the cost of silencing in most cases and can actually improve fan efficiency. Here's an example. You've probably lain awake at night wondering, how do they pull off the scrap aluminium cans for drinks off the line to recycle? Well, they have scrap fans and these suck damaged cans off the line and the cans pass through the fans and are shredded. Now this company installed 3 new systems to do this, which caused a massive environmental and occupational noise problem. They were quoted 35 grand per system to reduce the noise, but there would also be ongoing maintenance costs. Instead, using aerodynamic technology fitted inside the fan, that is a picture of a modified fan, the noise level reduced by 23 dBA, and it only cost £3,000 per system, and it will last the lifetime of the fan without maintenance, unlike silencers. So that's around 10% of the costs, and it doesn't have the hit on fan efficiency that conventional measures would have. Here's another motivational aid. A project in the States. This is an axial dust fan that clears dust off the inside of buildings. Using aerodynamic technology instead of a massive silencer, which just wouldn't have been practicable, we got a 75% reduction in noise level, 6 dBA off, which meant hearing protection was no longer required. 17% increase in flow velocity at 12 meters, which is efficiency, an 8% increase in airflow, etc. But also all this with a 7% decrease in power consumption. So you not only got improved efficiency as well as a massive noise reduction. So they would have done it just for the improvement in efficiency, not counting noise control. So this is self-financing noise control. Here's another example. Noise problems from a cooling tower. It was tracked back to the gearbox by the supplier, who was offering to change the whole thing for 31 grand. The company sent us a quick video. Frequency analysis and information about the gearbox led to us determining that the problem was the pinion on the gearbox, which replaced a fraction of the cost, completely eliminated the noise problem. But this is a specific identification of a mechanical problem with the gearbox that was causing the noise. And all that was done within 3 hours of them sending the video. Here's another example. This is a purchasing policy for some very large water pumps. The manufacturers of the motor and the manufacturer of the pump were arguing about whose fault it was that the noise levels were too high. They were 95 dBA when it should have been below 85. We carried out the diagnosis from the video. Which allowed us to determine that the problem was high frequency vibration radiated by thin panels on the plant. These were damped, 12 dBA noise reduction at virtually no cost. Another classic is hydraulic power packs. Now here's a picture of a hydraulic pack with a partial screen around it which knocked the noise by maybe 2 or 3 dB. However, it causes maintenance problems. If you stick an enclosure over the top, it also causes heating and you can't see leaks. Now this is a big problem because hydraulic power packs are not intrinsically that noisy themselves. You have a motor pump unit that's stiff, doesn't radiate that much noise. So the manufacturer then bolts it to a large oil tank to make sure the maximum noise possible is generated. The simple solution is to vibration isolate the motor pump unit from the tank using very simple isolation pads and flexible pipes. This can cut noise by between 10 and 25 dBA, very quickly, very cheaply, and without affecting maintenance. Pneumatic silencers and nozzles are a classic noise problem. There are probably 70 to 80 different types of silencer available on the market, and many of them are not very good. They have high back pressure and can clog. However, there are 0 back pressure silencers available, which we recommend. The bottom picture, if you have multiple air exhausts, you manifold them and put them through a single, straight through, 0 back pressure silencer. Very cheap, very convenient. As far as nozzles are concerned, you can buy off the shelf in training nozzles that are 10 dBA quieter for the same thrust and use 20% less compressed air. If you know about these, they will save you a fortune. Again, self-financing noise control. The difference between a pneumatic noisy site and a quiet pneumatically noisy site is just the practicalities of silencers, standardized on 3 sizes, and knowing about the possibility of fitting quiet nozzles. This is an adaptation of the technology used on the Millennium Bridge to control noise on the industrial plant. The Millennium Bridge had this swaying, and it was fixed by attaching what's called dynamic vibration absorbers underneath. Personally, I think they should have just charged for it as a ride rather than fixing the problem. But the same technology we applied to the flywheel of this bliss press. You've probably lain awake again, wondering what kind of machine makes the oil filter base plate on your car. it's these. They were going to spend £35,000 on an enclosure, but unfortunately they'd have to leave the door open for access. So that money would have been wasted. Using the dynamic vibration technology, which simply is a piece of steel on a cork gasket, we cut the noise by 10 dBA, costing about £20 materials and a fitter for half a day. Weighing machines is another common industrial problem, as are lots of other thin metal panels that radiate a lot of noise. In this particular case, typically they're 87 to 98 dBA in high hygiene requirements. The enclosure actually increased the operator noise level underneath by about 2 to 3 dBA. They cost £8,000 to £15,000, this sort of enclosure, and cause hygiene and maintenance problems because you have to strip it down to clean. Using engineering noise control, mainly laminated steel, 10 to 12 dB off at about 25% of the cost, 4 times the performance, very low cost, and it means that cleaning is no longer a problem, so it cuts the time to maintain and clean the machine dramatically. In this particular case, 94 dBA with the enclosure, 82 dBA with our technology used, and without the enclosure, so no hearing protection required on the platform. Now, the manufacturers of the weighing machines know what we do, but they make more money from selling you an enclosure. And just an aside, even on boilers, in this particular boiler, this is the only known case of yogurt-based noise control. Instead of turning the boiler house into a bunker, my colleague got a yogurt pot, modified it a la Blue Peter, fitted it inside, and on test, it knocked the noise by 16 dB. So now they just have aluminium yogurt pots inside the burners. Very, very cheap, but again, it's knowing that this sort of thing is possible. It gives you the option to reduce noise dramatically at very low cost. We've also developed a list of the top 10 noise control solutions that can be used to solve many, many common noise problems across many industries. These are available for free download from our website. It's open source. So these cover vibration control, which is vibration damping and vibration isolation pads for many common problems, for vibratory kit, for hoppers, chutes, guards, etc. There's also fan installation efficiency guidelines and aerodynamic noise control options. Pneumatic nozzles and exhausts that I've just talked about. There's also techniques to reduce chain and drive noise from timing belts and so on. Also reducing noise from electric motors and hydraulic power packs in detail. And also how to convert existing safety guards into acoustically effective guards. So you can download those at no cost from our website. One of the issues with noise control is just that people do not know what is possible. If you know what's possible, companies will implement low-cost technical solutions that cut the cost dramatically, cut the risk dramatically. So, as far as noise control is concerned, the key message here is that there are a lot of technologies that are available that are very, very low cost, do not affect normal operation of the plant or access or maintenance. If you know they're available, you can implement them. This means most companies can reduce their noise risk by 50 to 90% at virtually no cost. And in some cases, it will actually be a profitable exercise. You can either do this directly off our website by searching for the various solutions for your particular plant, or you can do it by sending us video and information by email, and we'll run it through the database and get back to you with your options. People can access this from anywhere on the planet at any time. So for more information, contact us, and if you've got any questions, I'm ready to answer them now.